Yeah, hello everyone. This is Sunil Kumar. I'm a student of AI and cyber security. This video is regarding about the midterm project. Under the guidance of AI and cyber security professor Benjamin Wahid, so we did this project. The basic requirement of this midterm project is to train the deep neural network and deploy the model through Amazon Saga Maker services and create a Python script that takes the PE files as a parameter and classifies one of the following binary classes like Benign or malware or malicious. The report is divided into three tasks based on the complications and approach to create a solution for each one of them. The task one is to do the pre-processing. And the task two is to do the training of the data set. And task three is the deploy of a model on cloud. So basically, we started with the task one to do the pre-processing of the data set. Actually, the data must be pre-processed and vectorized to be fed into a deep neural network. So we have used Ember datasets for doing this process, and we downloaded the Ember datasets from the Ember site. And there is a 2017 data which was downloaded, and we started doing the data pre-processing by using those datasets. So in this video, so we are talking about the pre-processing, saying that the particular data should be vectorized and we need to install the Ember library. So the notebook was created on the Amazon Saga Maker, but the student time we had access do not allow us to create big instances, and there was a limited access to Amazon Web Services. I'm sharing my screen to better understanding of this particular report. As I said this, this is the task one, which we are doing to the data processing. So by using the Ember dataset, we used this cloud server like TPU, GPU, Google, and TensorFlow and Colab. So step one is training and implementation. Steps two is deploying our model of the cloud and creating a client. So as we discussed about the pre-processing, as I said that the data set which need to be vectorized data, and we need to install the Ember library. So overloading the memory cache and some actually when you use this type of heavy use data, so there is overloading memory cache and session caches. So due to this, we decided to do the runtime session. So every time the session timeout are cached, therefore the normal segment just come with 5 GB disk space. So this data sets required a lot of more. So I had to take the space several times, and as I wasted a lot of time to do that. So I was used to the host data files in a Google collaboration, but AWS SagaMaker made my life easier in many ways. Though the files are referenced to NumPy's map, the data does not have to be loaded into the RAM at once. However, this should lead to the slow processing of the data, and to process these completely things in the machine learning model. It would take a while to download the data, first like 1 hour, the creating vectors to another hour also. So it took me 5 days to reach this step. After constructing the full data and training data sets, the full test data and their labels, and the training data has to be separated from the valid classes and unlabeled classes. However, it loaded all of the data into RAM. It was no longer processed. So it should be noted that being able to load the full data set into the RAM, the modest training task less time. So the last processing step for data is to standardize or normalize it. This is need to allow the neural network to converge, if not at least faster. The choose and normalize was standard scalar from the sklearn library. So the constraint architecture of the neural network between two general concepts, a model with conversion 1D as first layer after input layer at typical dense layer. It should be noted that because of the upgrade in the TensorFlow between 1.x and 2.x, there's some required reshaping is required to conversion the first D layer. So it is recommended to add and drop out layers to produce better generalization. So the addition of the number of nodes in the dense layer is the size of the approximately 2 by 3 number of the features 2381. The choice of activation functions for the following: relay for hidden layers, sigmoid for the output layer, and Adam as the optimizer set of landing rate to 0.01. So the wide architecture was recommended from the book Deep Learning with Python, Francis Cholet. So coming to the task to the training, for training it was recommended to two small batches. For example, the model that showed the data set did batches of 256 and mall conversion that come up with Ember did the batches of 100. The time varied depending on the RAM chip, but within an hour the model finished through one epoch, providing a promising 87 to 90% of accuracy. So 90% of AU, AUC and 90% of patient training data and 90% to 99% on validation data respectively. So after doing the first preliminary round, the model was set up for 30 epochs to see if the procedure better results. The model ran for all 30 epochs, but despite longer training, the model seemed to get progressively worse as all the performance metrics continued to dip. So when this happened, there was some altercations to the learning rate and batch size, but neither benefited the model in this case. The final evaluation was done on the test set receiving 98.5 to 97% accuracy, AUC, and precision respectively. So, so by doing all these tips, the task one will be completed. When coming to the task two, so we are deploying a model on a cloud. So the service used to deploy the model on Amazon Web Services is SageMaker, as I said earlier. So TensorFlow 2.0 is currently the most recent distribution of TensorFlow. And AWS will support TensorFlow 2.0 for training and deploying host to TensorFlow servers modelings from TensorFlow estimators. So, however, to import an outside trained model, TensorFlow model method used to convert a TensorFlow model into estimator. So by doing these steps, so finally we are downloading the TensorFlow 1.1 to recreating the architecture and loading the weights to resave the model was necessary. After getting the model to successfully import, the rest of the tutorial provided was sufficient. So depending on the Amazon Web Services account, the AWS Educate account stores their keys and password before launching the AWS console. So the creation of the endpoint took around 6 minutes while doing all these steps. So when enrolling the endpoint from the SageMaker notebook, response time was optimal less than half a second. So the final step is here to create a client. So I launched a virtual machine through AWS through EC2 service, specifically the distribution windows to create an environment to write the code. So this was an optimal testing environment for packages. Only one necessary file was bundled, that was pickle scalar file. Normally, a client shouldn't have this file. Instead of the file should be hosted with the Lambda function set to scale incoming data, but sets also restricted to student account and chargeable my personal account. So the Python script written was to the nano text editor and majority of the inputs are already on the client expert for Ember. So the response time for involving the endpoint returning data was around 7 seconds. So this is incredibly long for Marvel detection and therefore should not be recommended for general use. This encourages the concept of having light models distributed on the client for more optimal speeds. So finally, the conclusion is like the most competition delays are due to version incompatibilities and limitations in the services free tier than the objective themselves. This project should be forwarded to implement after knowing some of these complications. So I created AWS free tier account to learn them and implement them. I believe I have better understanding why all deployed systems are practically legacy products would be too unreliable otherwise. So most of them are big to download. So coming to the PPT which I shared, so the steps which we followed are this one. Then coming to the resources required for this is Jupyter Notebook, model training, evaluation, validation, matrix. So this finally, this model architecture is coming sent as a JSON file. So it will be used as an input to create a client. So this is the architecture overview of this particular project. So step one is to create a model archive, then creating a bio container, then train the model data sets, then coming to step to upload the model required to Amazon Saga Maker or EC or S3. Then finally we can have the AWS cloud to deploy the uh, particular requirement. Then coming to the step three, then launching the virtual machine with an OS on it, install Python and move necessary files and make a Python in the test editor. So this is the AWS Saga Maker instance which we created, and we have the results portrayed to that. So we received the results as explained. Second. Finally, we achieved the results as this particular requirement is, I'm sharing my screen for the results now. So this is the final outcome of these results where we came to know that is files, the file from the putty is like Bengine or malware or malicious. So thank you very much for viewing this video. And do you have any further questions? Let me know on this. Thank you.